Hey everyone! In this video, we're going to be looking at some right angle torque calculations. Now in right angle torque, we push perpendicular to the lever. It's possible to do torque where you're pushing at angles. That's not what we're looking at here today. So we have a 40 centimeter wrench, and it's placed on a nut such that the wrench sticks out to the right, which is going to become important in a moment when we try and draw this picture. We then push upwards on the handle with a force of 30 newtons, and we've been asked to solve the torque. So torque is a vector quantity, and we use the equation tau equals force times distance. And the force that we use is just the force that we're applying to our lever or to our lid or whatever it is that we're trying to open. And it's always measured in newtons. And the d value, that distance, that's just the distance that we're applying this force from the axis of rotation. So if you're trying to turn a nut, it's where you're pushing at the end of the wrench. Or if you're trying to push on a lever, it's where you're pushing at the end of the lever. We're going to go ahead and draw this little wrench here. So we have a nut, and my incredible artistic skills, I do my best. Come on, sometimes trying is important. So we have a wrench, and it's a beautiful wrench, and it's a 40 centimeter long wrench. And we're also going to be applying a force upwards, that was in the question, upwards with a force of 30 newtons. And now we actually have everything that we need in order to solve this torque. We can say that torque is equal to our force. Our force that we're applying is 30 newtons. And we're going to multiply this from the distance from the axis of rotation. That's 40 centimeters. But be mindful, we need to convert that to meters. So that's 0.4 meters. We multiply that out, 30 times 0.4, and we get 12. The units on torque, Newton meters. Okay, but torque's a vector quantity, so we use the right-hand thumb rule. In this case, our wrench is going to be going counterclockwise. See, my fingers go in the direction the wrench is about to move. That's counterclockwise. My thumb points towards me, so the vector comes towards me. That is a circle with a dot in it. You could also remember from my previous video that if we turn something counterclockwise, we are undoing it, which means we're bringing that nut closer to us, which is why we use the vector direction of the circle with a dot. That's the arrow as it's coming towards our eyeballs. We're going to do another question here. In this one, we have a seesaw or a teeter-totter, whatever you called it when you played with it when you were a child. Now, I like to say that people play on a seesaw. My students say that you can't play on a seesaw. They say you can sit on a seesaw, but you can't play seesaw. I disagree. We got a 50-kilogram person, and they're sitting on this seesaw, and they are 1.2 meters from the fulcrum in the middle. Okay, it's a big lever, and the person's sitting on it, no different than pushing. We do, however, have to convert the mass of this person into a force. You can't just say they push down with 50 kilograms. We have to convert that to a gravitational force. But that's within our abilities. If we can calculate torque, we can calculate gravitational force. It's F equals mg. Force is equal to the mass of the person, that's 50, multiplied by the acceleration due to gravity, 9.81, and that means that this person is pushing down on the seesaw, pushing down on that teeter-totter with 490.5 newtons. Now put the little arrow, they're pushing down. We pushed up on the wrench, this person's pushing down on the teeter-totter. We can calculate our torque. The force that they're pushing down, 490.5. The distance that they are from the fulcrum, 1.2 meters. It's already in meters. We get our torque as 588.6 Newton meters. But what direction? Well, right-hand thumb rule, if I take my hand like this and I put my fingers in the direction that teeter-totter is about to go, because it's about to go clockwise, my thumb points towards you, which is away from me. That's an away vector, a circle with an X. You could also remember that if something is going clockwise, that is tightening, that is moving away from you. Counterclockwise towards you, clockwise away from you, a circle with an X. However you want to remember it, that's how you get that torque value. But to do the calculation, you only need the force times the distance. I hope that this was helpful. Thank you very much for watching, and I'll be looking forward to seeing you next time.